Good afternoon, welcome. Really glad to have the post-lunch slot. I hope everyone's got lots of coffee. Yeah, I'd rather have yawns than snores, so yeah. If you feel the need to get more oxygen, I won't be offended. If you fall asleep, I might throw something. So, Richard and I are here today to talk a bit about not only what we OUP do, which is involved in the architecture of our XML data models and getting it captured and getting it QA'd properly, but also in applying XML to our own workflow through a particular case study. So we decided to call it Practice What We Preach. Many thanks to Sebastian Ratz, who just pointed out the last preachers from Oxford managed to get birds at the stake. Hopefully that's not going to happen today. So I'd like to lead by talking a bit about the situation we have at Oxford University Press. And in our team alone, one of the biggest challenges we have is that we've got such a wide variety of author inputs. Earlier on we had a disclaimer from somebody saying he was talking mainly about the data aspects of XML rather than the markup aspects. We live very much in the markup documents world. And as part of that variety, we've got content like academic monographs, some of which are not only from OUP, but actually from partner publishers who are capturing to our format through the University Press Scholarship Online. We've got specialist chaptered contents, such as original folio editions, side-by-side content. We've got legal monographs. This one's launching in July with quite complicated legal citation markup and linking. We've got some very highly designed higher education textbooks, as well as professional works like medical textbooks and medical handbooks, which have obviously got a lot of specialist content, drugs and diagnosis information. And there's non-book content as well. It's not all chapter content. So we've got this series of author bibliographies, which are meant to give an alternative to the statistics-based Google searching. We've got Oxford reference content, again both in sort of general flavour and some legal titles. And going into law in September, we're launching Oxford Constitutions of the World, which involves content not only from our own authors in terms of commentary, but also legislation that's been passed from countries across the world, and even places within countries, different states in the US, and existing products like Oxford Reports on International Law. We've got law reports and commentary on law reports, again written not only by authors but potentially by any court in the world. And later on this year we've got some products that combine almost all of these types of content. So we've got a very wide range of content coming in from different authors, different sources, and there's a clear requirement here to preserve the quality and to reflect the authority of our expert academic authors. But there's also an inherent conflict, because all of these contents have to be captured into a single set of quite complex but related data models. And this is carried out by typesetters, normally in India, or by a few specialist XML keyers in the case of some of our specialist content. And we have to ensure that they balance the need to preserve the richness of our content against the requirements of our data model, so that we've got consistent data that can be reused in different outputs for single source publishing. So even before we think of steps like even before we think about steps like validation and QA tools, we need to provide good documentation to the suppliers in India. And the way we've been doing that is by a set of documents that we call text capture instructions, or, because we all love TLAs, three-letter acronyms in this business, TCIs. I'm going to invite Richard, who is a supplier who worked with us for a number of months last year, to talk a little bit about the situation with our TCI.
Hi. Yes, so the TCIs were written in 20 to 30 Word documents. There were about 2,200 sections, and the documents for the specific products and titles, some documents with specific products and titles, and some for the core DTD structures reference from specific products or titles, so there was a hierarchy in there. And the data engineers managed these in SharePoint across several SharePoint sites, so they had a live site for the typesetters and a site where they made the updates and then released them once a month, I think it was. So, there's a click. Yep. So this was a challenge because they were hard to write well. There were multiple authors updating the instructions, and the instructions were duplicated in several layers of the documents, which led to partial updates where they'd update it in one but not the other. The typesetters, faced with the word TCIs arranged in a confusing hierarchy, which was a separate hierarchy from the DTDs, were unclear of the precedence of the instructions and which one they should follow. And there was no writing style guide, there was nothing guiding the authors. So words like sometimes, normally, generally, should, would, might were used in virtually every sentence. So it was never clear that they should do it. It was suggested that they should capture it in a particular way. Also, the audience, the typesetters, were confused because many of the instructions were actually for other audiences. For example, the DTD maintenance notes to the data engineers. In all complex, inconsistent, difficult to maintain and difficult to navigate. And worse still, for XML engineers, people who are used to precision, there was no effective way of validating or QAing any updates that they made. So at that point, they decided they were going to hire a technical author, which is me, to help them convert it into XML and do some rewriting. Okay. So they'd already picked the solution. It's a vocabulary called DITA XML. Has anybody heard of this vocabulary? All right, a majority, okay. So I'll run through it for the others. Basically, tech writing changed over the last 30 years, and computers and the web meant that tech writers were dissatisfied with linear documents as promoted by MS Word, which is what OUP had. And we wanted the freedom to collaborate, chunk information and recombine it as we saw fit. Sometimes a nice manual is still appropriate, but we can build those from chunks. And guess what? They're better for it, in fact, once you separate the chunks from the context. When you look at a printed document like a manual, and each chunk has its own context, it's easy to get the information you want right there without relying on kind of a narrative through the book. Practically speaking, we're talking about a database of XML files and maps in the vocabulary, DITA vocabulary, mapped into books, web or help, and then published through XSL to the final output. And conveniently for this project, publishing industries have been pursuing XML single source solutions over the same time frame. So in the tech comms world, one solution, this solution, came out of IBM 10 to 12 years ago as a set of DTDs called Darwinian Information Typing Architecture. And following a great deal of progress at IBM in the study of what is and how to ensure quality technical information, they needed a new semantic scheme to make use of their findings. A scheme for creating modular content, tying it together and publishing from a single source to multiple channels. In addition, they needed a mechanism for capturing new semantic types in a lightweight way. So DITA is Darwinian because it allows inheritance and specialization through the DTDs. Where an editor or publishing chain is not aware of the new semantic element, it uses the processing or presentation of the parent of that element, which means you can capture the semantic content more or less immediately after changing the local DTDs and work on implementation later on. and capture the right content and presentation can follow later, which adds up to savings. And in a global organisation like IBM, there's a great deal of savings, sort of dollars. But Ditter XML is more than just single sourcing technology, and it's more than just a technical solution. Because of its roots in this search for quality information development, it's actually a writing methodology and an ethos, and there are resources to help you with that. It borrows from minimalism, which is a movement in tech comms to give the minimum effective dose of documentation, which means no superfluous clutter. It requires you to be direct, using commands and the active voice to address the right audience. And it's based on user tasks. It focuses on the audience, tells users what to do, and doesn't assume they'll work out what they should do if you give them all the details. And all this adds up to quality, happy readers, and corresponding reduction in instructional errors. So hopefully you're now sold on Ditter if you weren't already. And the good news is that IBM open sourced the whole lot in 2001. That's the DTDs and something called the Ditter Open Toolkit, which is a processing framework. And tools vendors such as Oxygen XML Editor now offer excellent support. So it's easy enough to implement. This is a case study, so I'll just run through what I did at OUP. It was Christmas last year I started, and I worked through the Word documents, removing the headings and rewriting the headings and applying semantic word styles to the document content. Then in the second stage, I configured Elliot Kimber's excellent Word to Ditter XML transforms, and used those to convert the Word documents into Ditter XML. And finally, I rewrote over 2 months the 2,000 plus raw XML topics into 1,300 minimalist topics, whilst restructuring the 22 maps, one for each Word document, into a knowledge-based Ditter map. So just to give you a feel for the simplicity of Ditter, of the underlying XML, each topic was stored in a .ditter XML file in Subversion. And you can see that the elements are semantic. The tags are concerned with the meaning of the content and don't describe style information. And then the topics, the .ditter files, are linked together in a .ditter map with the hierarchical structure described by the nesting of these topic reference elements. In addition to that, there were keys in the topic map and in links in the files that allow abstraction of links that's controlled centrally from the map, which Tom will talk more about. During the project, I worked with Tom to make various global changes in the content, including several data integration features. But I'll allow Tom to explain what must be for the typesetters one of the biggest wins from the project, and that is single source validated XML examples.
So we're a team of XML experts. Well, we like to think we're experts. We've certainly got a lot of highly developed and frequently used XML skills. An XML document format seems obvious. It makes obvious sense and it's an obvious improvement. Just because we're not restricted by a serial format like Word. But there are other improvements where we can apply our XML skills. Richard mentioned in passing conversion, the actual conversion process I'm talking about here, into Ditter, as well as conversion to output formats. We've got the potential to use content reuse, both in terms of within the Ditter architecture, because you can call in using keys and reuse sections of content without having to reauthor them or hold them in more than one place. But we're also able to do some clever things with source control systems and version control. We can automatically date topics, so we can display to the end user when when that was last updated. We've actually able to, because it's an XML format, it's subject to the validation tools that we already know and are familiar with, we can apply quality control to the documentation itself. We can do a lot of output customization in XSLT. Example would be that we've got footers at the bottom of each of our topics, so that if we get feedback on a particular text factory instruction, which is no longer relevant or it needs clarification, we can come straight to the place in the disk file that needs looking at. We can look at integrating the XML into other systems that we've got already. I've already mentioned version control. So there are all sorts of places, anywhere we can think of an XML technology, there's probably an application here that we can use and apply the XML we're using in our own processes. But as Richard said, this is a case study, and I want to zone in on one particular example, and that's around content reuse and quality control in examples. So here's the problem. We've got an example output at the bottom. It's a bit small, I hope everyone can more or less see it. It's a very simple XML fragment with a disclaimer, which is a very, very bad label because it's actually a copyright notice. And it's about Singaporean law reports. So the problem is that examples and data models that examples are based on will change. You get changes in the data model or changes in the business rules, which either invalidate the XML or just have backwards compatible changes which aren't reflected in the example. And if they're not there in the example, we quite often find that typesetters will ignore the requirement to put them in. And it does result in bad capture. The example's now incorrect or incomplete. The other issue, which is not immediately obvious, is that the cause of this error, this outdatedness, is not always the subject of the example itself. So you can have an example in a completely different subject area to the thing that's actually changed in the data model, that because it has to be valid and well formed, contains the old obsolete XML. It's really easy to miss that when you make an update to a completely different part of the document. Another slightly lesser problem, perhaps, is that the example styling is a real pain. Every one of these different colours and different elements, the attribute values, they're all marked up, and each one is a separate element in DITA with output classes that are going to tie into CSS classes later on. It's basically a complete waste of our time. It's also inconsistently applied, because every data engineer has the way he thinks it should be styled. We've all got different colours in our Oxygen customizations, and everyone just copies and pastes straight from theirs. The other thing is that because it's obfuscated into an XML serial view, it's very easy to miss the obvious. Solution was actually very simple. We write XML examples in the native XML. We can validate that XML using MVDL and a wrapper XML format, so all the XML examples are held together in a single file or single set of files. We can then transform that file to a DITA topic and reuse the examples in that DITA topic using DITA share and reusing. Here's an example of the wrapper format that we've come up with. You can see, again, using Oxygen's nice colour coding, we can actually change the colours between the wrapper XML format and the example XML we're containing, and they've got different namespaces and therefore different data models. So just point out some of the relevant features. The big scary green line is just an Oxygen processing instruction to make sure that's associated with the MVDL schema, so it's there and available for anyone editing this file without them having to do too much settings in Oxygen themselves. We can see that we've given a unique ID to the example itself. The format of the examples file overall is very simple. It's the examples root element and the number of example elements within that. We've given ID on the example instance. That's used as a key in DITA later on for sharing. And then within that we've got a single element which chooses by name the data model that we want to validate the contents with. You see the contents here don't have a namespace. That's because our data models are still based on DCDs because of legacy requirements. So we don't really want to use namespace-based validation, but that's okay. NVDL will now support sort of contextual validation based on element name. Bringing us on to NVDL, has everybody heard of NVDL? Okay, so maybe more people have heard of DITA. NVDL stands for Namespace Validation Dispatching Language. It is, I believe, something that's originated W3C specs. I've got a sample of the full paper which I think will be available to you all, so we can go into it in a bit more detail. We don't really have time or screen real estate to go into it in very much detail here. But it is, as the name suggests, a method of validating XML fragments within the same document based on their namespace, or indeed from contextual information. Our data models that are being called in by NVDL to do the validation on the fragments are included using SVN externals, so they're always kept up to date. And they provide not only grammatical validation, but also the wrapper XML format, but also the example XML format. And you can also use Skimtron validation for rules-based validation. At the moment, we're using that for ID uniqueness within the examples. We use a different rules-based validation system at the moment called XML Probe. We're looking to move on to Skimtron validation later, which will make this exponentially more powerful at ensuring the examples meet business rules. And of course, because we've got that validation in the editor, people writing the examples can tell as they write the examples whether they're correct or whether there's a conflict. Transforming to DITA topic, I was expecting it to be quite difficult. It was a dead simple piece of XSL, and it means we've got consistent styling with one click. The output CSS that we see on the final output of the DITA is actually reused in the editor, so the structure is obvious to the author at a glance. And just to compare, we've got the output example which I showed you earlier, and there's a screenshot from within Oxygen. So we know it's going to be consistent. And share and reuse in DITA, because we can call in content using that key, which is the same ID that we saw earlier in the examples.xml file, it can be reused. And we've got single source XML, which, given that that's the thing that we're trying to sell to the publishing industry as XML data engineers in the publishing industry, is very pleasing that we're actually putting our money where our mouth is. So XML is a very powerful tool for reuse and abstraction, and that reuse can be applied to our own skills and processes, and that's the conclusion that I want to take away with us today. And again, to reiterate that any technology that's available for the wider use of XML may introduce opportunities for your own processes. I can't leave without saying that we found that those principles of reuse are also mirrored in DITA's conceptual guidelines for helping us write as well. Thank you very much for listening. Are there any questions that anybody got for either of me or Richard?
Beyond your type specs, do you employ any DITA concepts into the data that you hold through your information, books and journals and things like that?
The data models that we're actually capturing to are custom data models for books, so we don't actually have any data in those yet anyway.
Okay.
No, but we are looking at reusing DITA for our own internal documentation as well, and extending some of the tool sets that we've got.
Great. It's just worth mentioning as well that I think Hillman's DITA for Publishers plugin is designed for books, for publishing. And you can plug that into DITA in about 10 minutes, and you can generate, Kindle books or PDFs from that.
I think No, I think it's very much like DocBook as well. There are lots of standard data models out there, and there are huge advantages to using those if your source content is actually going to be supported by those. We find a variety of input content requires custom data models.
So it's not suitable for STM, for example.
So, do you still have multiple authors that are updating your documentation? And if so, how are they adjusting to fit the model?
Well, there are a couple of them here today, so we could ask them. I think there's certainly a learning curve, because we can't just go in and muck about in Word anymore and just put what we like there. There are some rules and some structure. But actually, those rules and that structure and that validation are helping to improve our documentation and ultimately improve our product. So I think although there's a learning curve, we're getting a bit better at it, and we've had some very positive feedback on the standard of our documentation since, so definitely worth it.
Any further questions for Tom?
Just want to mention that the XML model processing instruction is not oxygen specific. It's a W3C node that describes this processing instruction to associate a schema with a document. When we implement that node, so it's not oxygen specific.
Well, why would you want to use it with anything else though? Pay me later.
Okay.